Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we will study about active components. In case of active components, we will study about voltage as well as current sources. First, let us see different types of electronics component. Mainly, it is divided into two different types. One that is active components and another that is passive components. If we define the difference between passive component and active component, then we can say that passive components are those components which cannot deliver the power. Passive components are those components which cannot process the signal. They absorb the power. And some examples of passive components, that is a resistor, inductor, capacitor, etc. They absorb the power, but they are not able to process the signal, neither they deliver the power. On the contrary, if we define the active components of the circuitry, then we can say that they are energy sources. They deliver the power. An example of energy source, that is a voltage source and current source. Active component are signal processing component. They can process electronic signals. And the example for signal processing components, that is transistor and a lot of other active components. So in today's lecture, we will study about active component, that is a voltage and current source. Now let us start with voltage source. Voltage source normally supply voltage. We have DC voltage source as well as AC voltage source. First, let us see ideal voltage source. We have different symbols and we'll study the characteristic of the ideal voltage source. We have DC voltage source, that may be a battery, and this is symbol for the battery. The voltage that is taken at the terminal A and B, and the voltage level that is indicated by the Vs, S we use for the source and V for voltage. Same way we have AC voltage source, and this is symbol for the voltage source AC, and the voltage taken to the terminal A as well as B. In case of ideal voltage source, as we connect a load across the terminal A and B, and if we go on increasing the load current, there must not be a decrease in the terminal voltage. Now let us see the characteristic, then it will be very clear. We have x-axis as well as y-axis. On the x-axis, we have taken load current, that is IL. On the y-axis, we have taken terminal voltage, and with respect to load current, if we draw the characteristic of the terminal voltage, then it remain constant irrespective to level of load current. Meaning is, if load current increase to any such value, terminal voltage remain constant, that is the source voltage Vs, for any value of load current. In the voltage source, ideal voltage source, there is no internal resistance, or internal resistance is zero, and that is the reason why voltage remain constant throughout any load current condition. There is no any voltage drop at the source. But ideal voltage source is only a theoretical concept. There is no such ideal voltage source. We always have a practical voltage source. The meaning is, we always have some resistance or impedance in case of AC voltage source exist in series with the source. So now let us see practical voltage source. First, for the DC voltage source, we have some internal resistance connected in series with the source, and that is known as RS. R, that is for resistance, and suffix S we use for source, and then the voltage is taken to the terminal A and B. Same way for AC voltage source, some impedance is connected in series with the source, that is known as a ZS. Z we use for impedance, and the voltage is taken to the terminal A as well as B. Now, in case of practical voltage source, as we connect a load across the terminal, and if we go on increasing the load current passes through the source, that will pass through the series connected resistance as well as impedance also, and across a resistance or impedance some voltage will drop, and because of this drop there will be slight decrease in the terminal voltage as the load current goes on increasing. Now let us see the characteristic. On the x-axis we have taken load current. On the y-axis we have taken terminal voltage. Now in case of practical voltage source, we have constant ideal terminal voltage with respect to load current, but practically we have slight decrease in the terminal voltage as load current goes on increasing. Some voltage will drop across series connected internal resistance or impedance. So this is our actual terminal voltage characteristic with respect to load current. So we can conclude that in practical voltage source, there is always a certain amount of series connected internal resistance or impedance exist, and always there must be certain amount of voltage drop across the internal resistance, and that affect our terminal voltage. Now let us consider current source. In case of current source, it supply a constant current. It can be a DC current source, it can be a AC current source. So first we consider the ideal current source. We have symbol for the current source. It can be a DC current source, it can be a AC current source, and it is taken to the terminal A and B. Same way we have AC current source. We indicate with the instantaneous value of the current, and current is taken to the terminal. In case of ideal current source, if we connect a load across the terminal and if load impedance decrease, meaning is if load current increase, source current always remain a constant irrespective to any value of load impedance. Let us see the characteristic. On the x-axis we have taken load impedance. On the y-axis we have taken terminal current. In case of load impedance increase, source current always remain constant in case of ideal current source. The meaning is there is no any internal resistance or impedance connected across the source. But ideal current source never exists. It always has certain amount of internal resistance or impedance connected across it, that is parallel to the source. So now let us see the practical current source. We have DC current source and certain amount of resistance, that is the internal resistance, is connected across the source. And same way, in case of AC current source, some impedance, internal impedance is connected across a source. And if we see the characteristic, on x-axis we have taken a load impedance, on y-axis we have considered current. Ideally, current should remain constant irrespective to any load impedance. The meaning is if load impedance value increase, terminal current should always remain constant. But practically, current source has certain amount of internal resistance or impedance is connected across the source, and that is why practically there must be some current drops and we have certain amount of decrease in the terminal current as load impedance increase. Thank you for watching my video. Keep watching. Thank you very much.